In this project, we will learn how to control a piezo buzzer with a push-button switch. Essentially, when the push-button switch is pressed, the buzzer will sound. It will continue to sound once the switch is engaged, and when it is released, the buzzer will stop. Let's take a look at the objectives for this project. By successfully completing the project, we will have mastered the following items. You'll understand how a piezo buzzer works, how to wire a piezo buzzer in a circuit, the difference between an active and a passive buzzer, using the tone function and also using the no tone function. If you're ready to begin, let's get this project started. Here are the parts that we will need: an Arduino Uno, our USB cable, a breadboard, a piezo buzzer, a 330 ohm resistor and a 1 kilo ohm resistor, a push-button switch, and connecting wires. Before we get to our circuit, let's talk a bit about the difference between active buzzers and passive buzzers. We will address active buzzers first. Active buzzers generates the sound itself using an internal oscillator. What this means is all you need for an active buzzer is to apply a DC voltage, similar to how you would turn an LED on and off. Depending on the buzzer, you might also need a transistor to give a power boost due to higher current or voltage requirements. On the contrary, for a passive buzzer, you need to provide an AC signal to control the sound. In order to facilitate this, Arduino has a handy built-in tone function to accomplish this, and we will look at this in more detail a little later on in this lesson. A piezo passive speaker can use the Arduino to drive it. It doesn't necessarily require an external power source, and you can also control the pitch of the sound that can be heard from a passive buzzer. So those are a few differences between active and passive buzzers. For our project, we'll be using a passive buzzer. Let's take a look at our circuit diagram. First, we connect the ground pin from the Arduino to the ground rail. And then for the buzzer, we have the negative pin of the buzzer being grounded via a 330 ohm resistor. The positive pin of the buzzer is connected to pin 9 on the Arduino. For our push button switch, one end of the switch goes to pin 7 of the Arduino, and also there's a 1 kilo ohm grounded resistor. And then finally, the other end of our switch is connected to the 5 volt rail, and we complete that connection on the Arduino. Let's wire our circuit. First, we'll connect the piezo buzzer. If you look at the top of the piezo buzzer, you'll see a plus sign. That's where the positive pin is, so just be mindful of that when you wire up the circuit. Next, there's a 330 ohm resistor that goes to ground. The positive pin of the piezo buzzer goes to pin 9 on the Arduino. Next, I'll connect the push button switch. One end of the switch goes to pin 7 on the Arduino. There's also a 1 kilo ohm resistor from that particular end as well to ground. The other end of the resistor goes to 5 volts. So I'll make that connection to the 5 volt rail. And then finally we have to wire up the actual 5 volts connection the 5-volt rail, and ground. Okay, that completes our circuit diagram. Now I'll go ahead and upload the code. Right, now I'll test the circuit out. So as you see, when I press the button, so as you can see, when I press the button, the buzzer makes a sound. And I keep holding down the button, the buzzer continuously makes a sound, and as I take my hand off the buzzer, it stops. Let's take a look at the code. So at the top, we define our buzzer pin being pin 9 of the Arduino, and then our button pin is connected to pin 7. In our setup function, we do a pin mode button pin input, saying that we're taking readings from the button pin, and essentially, in our loop function, if the digital read of the button pin is high, that means that we need to sound the buzzer. So in order to do that, we use the tune function, which takes 2 arguments. The first is the buzzer pin, and the next is a value for the frequency of the sound. So that would cause the buzzer to sound. Else, if the digital read of the button pin is low, we call the no tune function passing in the buzzer pin, and that stops the buzzer. If we take a look at our circuit diagram again, you'll see that once the push button switch is engaged or pressed, essentially, and if a reading is taken at this pin, it would be connected directly to 5 volts. Hence, if the reading on the switch is high, we know that the buzzer is being pressed. If on the other hand, the reading is low, that means that the reading at this particular pin is directly connected to ground via the resistor. There's a break in the circuit because the switch is not being pressed. We know that we need to not sound the buzzer, and we accomplish this by using the no tune function. So hopefully that explains the operation of the circuit and how we take the measurements in code. To summarize, in this project you learned how to control a buzzer using a push button switch. You were also introduced to the tone and no tone functions for controlling the buzzer. A buzzer can be a useful component in projects as an alarm and a general-purpose auditory device. You now have the knowledge to incorporate it in your projects. Let's move on to our next lesson.